Hey guys, so we are gonna be comparing variability today. So comparing two sets of data and how they vary compared to each other. Okay, so um, basically, I think the easiest way to think about this is with dot plots. They're going to be two identical, generally identical dot plots, um, right? But when they're double dot plots or line plots, they're above each other. Um, the shape of them is all the same. And then it's just where are they on that number line compared to each other. That's really the variability that we're talking about. So um, again, if you look on here, it says when the answer is 0, it is completely overlapping between the two data sets. So there is 0 difference. It's this data set and this data set. They're exactly the same. They are one on top of the other. Each number matches up perfectly. 0 difference between them. Okay. And then as the number gets bigger, it spreads out more and more. Okay, so here's 0. There's 0 difference. And then 1, this is a lot overlapping, right? There's just 1 or 2 little points over here and over here that don't quite line up. And then 2, 3, 4, 5, right? It keeps going until maybe eventually there's nothing overlapping anymore. So 0 is completely overlapping. I usually say like 1, 2, 3 is a lot. 3, 4, 5 is a little. And the only time I say that there's no overlapping is if they give me the exact set of data, like these are the numbers, which a lot of times they're not going to do, because could possibly be that maybe there's one outlier that like the two data sets are way spread apart, but then there's this one little outlier that's just here, so it's still technically overlapping a little bit. That's the only time I would say no overlap. Otherwise, I would stick with a lot for 0, or sorry, completely is for 0. That's the only one that can be completely. And then 1, 2, 3 would be a lot. 4, 5, 6, anything more than that would be a little. There's not a specific cutoff number like once you hit 20, now it's no overlapping. There's nothing like that, unfortunately. So we just kind of have to do our best with that. Okay, so the way we actually find this is, here's our formula right here. We're going to find the difference of the means. So they're going to give you two means, and then, so for the difference, we're going to subtract them, and then we're going to divide it by the MAD. They're going to give you the MAD too, usually. So you're going to have all these numbers. You're just going to have to plug it in here. So find the difference of the means, so subtract them, and then divide it by the MAD. Okay, so now we are going to actually solve some. So remember, we're going to use that difference of the means divided by the MAD, which is asking us right here. I did go ahead and give you the graph, the pictures of the graphs on this one, just so you can kind of see how it works. Again, notice it's like the exact same two pieces of data. It's just shifted over a little bit, okay? And to save us some time, I already found the mean for both age groups and the MAD. Notice here that the MAD is this exact same, 6.25, 6.25. They should be. They're going to give you two sets of data that have the same MAD. And that makes sense because right here, if this is the exact same picture as this one, right, just shifted, then within the data, it's varying the same amount on the top one and the bottom one. Okay, so now to do the difference of the means divided by the MAD, we are going to take the two means, the bigger one, 85, minus the smaller one, so minus 70. That's how I'm going to find the difference of the means. And then I'm going to divide that by the MAD, which again should match. So divided by 6.25. Go ahead and write that on your paper and use your calculator real quick to figure it out. I'll give you a second while I use mine. Okay, when I did 85 minus 70, I got 15. And then 15 divided by 6.25 is 2.4. So let's go ahead and type that in right here. we should be getting 2.4. Okay, and then where we talked about 0 is 0 difference. They line up perfectly. And then as the number gets bigger, the more that they differ from each other. So the more variation there is. So this would be completely overlapping. This is not completely overlapping, which you can see in that picture. If you look at the picture right here, they're not completely overlapping. There's a few over here that aren't overlapping and a few over here. So we know it's not that. 2 to 3, right? 1, 2, 3, we said those are all pretty good, where it's a lot of overlap. So I would call this a lot. And again, if I look at the picture, I can see all this middle chunk, like all of these things are overlapping. That's a lot of data that's overlapping. Okay, so I would call this one a lot. Okay. And I think we're ready to do another. So when we go to this next one, same idea. I gave you the graphs just so we could again kind of see how it looks. And I gave you the means and the MAD. So let's do the same idea. Go ahead, I'm gonna let you try, set it up. Let's see if you can get the right setup for the difference of the means over the MAD. Just set it up first. Okay, I'm gonna go ahead and set mine up. So the difference of the means, I'm gonna take the bigger minus the smaller. So 85 minus 65. So I find the difference of the means, and then I'm going to divide that by the MAD, which again, our MADs match 6.25. Make sure you had that set up properly, and then go ahead and solve it. Okay, when I subtracted, I got 20, and then divided by 6.25, and I got 3.2 for my answer. So let's go ahead and type that in here. 3.2. And then it says, how much do these two data sets overlap? So again, if I just kind of look at the graph, that's kind of helpful. This one's a little tricky. 3.2, we kept saying that 3 was still kind of a lot. Maybe it switches to where it's a little. This is less than half of the data. So I'm thinking this might be closer to a little than it is to a lot. It's a little tricky. We definitely can't say none. The picture shows that. 3.2 is not big enough to want to even try to say that. So I would think that we should go with probably a little overlap for this one, just because it's a little less than half of the data, right? So somewhere in here, if there were 2 more dots overlapping somehow on both sides, that would be half of it. So since it's less than half, I'm going to say that it's a little overlapping. Okay. I want to do one more with you that doesn't have a graph, and then I'm going to have you do some more on your own. So let's go to the next slide. Okay, so here it's just straight up. They gave us the means and the MAD. We're going to do the same exact thing. There's just no graph to help us out. So go ahead and get it set up. Do your difference of the means divided by the MAD, and then come back to me and I will do it with you. All right, so hopefully you already did it. So if we're doing the difference of the means, I'm going to do 70 minus 50. There's the difference of the means divided by the MAD. So when I subtract, I get 20, and then divide by our MAD, which was 5. And that gives me 4 for my answer. Okay, so we should have that typed in right here. And 4, again, is starting to get where there's not as much overlapping, right? 0 is where it's 0 difference. They completely overlap. And then 1, 2, 3, 4, right? We're getting littler and littler. So there's just this little piece right here overlapping, and all this other stuff, right? It's not overlapping. So this one I would definitely say a little. And there's no perfect number to tell us exactly, but I usually say after 3 is probably when it's switching over to a little. So a lot would be that anything bigger than 1, right? So like 0.5 up to about 3, that would be a lot. And then a little is beyond 3. Okay. So there are just a couple more I want you to do. Same idea, make sure you're inserting your pictures of your work and typing in your answers, and that's it. Thanks, guys.